Example number 2. This one is a little funky because we are going to end up doing long division, but we can't right now. To do long division, you need whole number exponents. And the exponent on this one is going to be a 1/2. I cannot do long division with fraction exponents. So I'm going to start by doing something a little weird. I'm going to say that this whole thing right there, that square root of x, I'm going to set it equal to a letter. We'll just pick one. Let's pick v. Let's do v. We're going to say that equals v. So we're going to say v equals square root of x. The first one I'm going to do, so with this equation, my v equals square root of x, you can see I already did here, is I'm going to square both sides and solve it for x. So now I've got x equals v squared. Now I'm going to do something kind of weird. I'm going to take the derivative of this equation. So I get dx equals 2v dv. Now let's start to plug things in. So I've got 1 over square root, x is v squared. So far so good. Dx is 2v dv. Right there, I just substituted it in. So now I'm going to move that 2v up. So 2v over square root of v squared is v minus 1 dv. Now if I look at this problem, now I can do long division because the biggest exponent on top is a 1, biggest exponent on bottom is a 1. And anytime the biggest exponent on top and bottom, or the degree on top and bottom, are equal, that's a long division problem. So that means I'm going to start by doing 2v divided by v minus 1. So I had to do all this weird stuff up here just so I could get to a point where I can do long division. Now, same process. This one times what equals this one? And I should probably do my placeholder of plus 0. Well, v times 2. And line it up in my numbers column. Now I'm going to multiply it in. So v times 2 is 2v. V times negative 1 is negative 2. Subtract, change all the signs, change that to a subtraction, change that to addition. Those cancel, 0 plus 2 is 2, so that is my remainder. So now I can rewrite this problem as 2, my answer, plus the fraction remainder over what I was dividing by. And now this is doing exactly what we did the first time, where you're going to split it up and solve each of them individually. So this first one is still easy, just going to be 2v. This next one is going to be a u substitution. I want you to pause the video and try to do the u substitution for this one on your own, and then come back and check and see how you did. Let's see how you did. So this first one, I'm going to set that to u. So I get u equals v minus 1. So du equals dv, because the derivative of that is just 1. So that right there is a du. So because I don't need this 2 in this derivative, I can move it out front. So I move the 2 out front, and now I'm left with 1 over u du right there. Well, the integral of 1 over u is ln of absolute value of u. So now I've got this. So I start by substituting u back in. U was v minus 1, so I'm going to put that in for u. And then I need to substitute v. V, from way back when we started, was square root of x. So that's square root of x, and that's square root of x. And that should be your final answer. In the next video, we'll talk about our last integration technique, which is integrating with our inverse trig functions, so arcsine and arctan.